The chi-square test for independence is the third and final type of chi-square test we will learn. It tests for an association between two categorical variables in one population. How is this different from the other tests? Well, let's go back and review. The goodness of fit test is one variable in one population. So take one sample and ask one question, such as take a sample of M&Ms and ask, what are the proportions of the colors? The homogeneity of proportions test is one variable in two or more populations or treatments. For example, the treatments might be having surgery to reduce your epilepsy or taking drugs to reduce your epilepsy. And then the question being, have you stayed seizure-free for a year? And then the one we're going to do today is two variables in one population. Take one sample and ask two questions. Let's go ahead and look at an example of that. Among Hillcrest seniors, is there association between gender and having a driver's license? Suppose that a random samples of 100 Hillcrest seniors was taken and the subjects were asked their gender and whether or not they had a driver's license. Does the data suggest that an association exists? And again, this is kind of confusing because you could almost tweak it and say, well, this is two populations and one question. Bottom line, mathematically, the test is the same. They're usually fairly clear on an AP test as to which one you need to do. And I don't have any better way to explain it to you, and I'm sorry about that. But in this case, we're asking the question, are you male or female? And not using them as two separate populations. And I guess the sampling method does make it different because you didn't go and sample a certain number of males and a certain number of females. You went out and just sampled 100 people and note down whether they were male or female, which makes this the independence test versus the homogeneity of proportions. Okay, so among Hillcrest seniors, we're looking to see if gender has a role on whether or not they have a driver's license. And out of the 100 people that I surveyed, this is how it turned out. 36 males had a license, 11 did not. 32 females had a license and 21 did not. And again, with this type of test, you do not want to force, oops, excuse me, that's the wrong direction. You do not want to force the number of males and the number of females to be the same, or you invalidate your test. You can just say, I'm going to survey 100 people, randomly pick them, and then I say, are you male? And do you have a license? One population, two questions. Okay, and if there is no association in the two variables, what would the expected counts be? Well, again, we could do the shortcut, which is row total times column total all over total total. And really the question we're asking is, what's the probability of being a male and having a license? That would give us this part of our expected table. And so we would think about it as the probability of being a male, 47 out of 100. Okay, 47 guys out of 100. Probability of being somebody that has a license, 68 out of the 100. But we don't want a percentage, we want to count, so then we would times that by the 100 people. And when this 100 and this 100 cancel out, that's our calculation, which fits our shortcut. Or in this case, 31.96. So exactly what we did for the HOP test, but let's put this in our calculator instead. So we're going to go to second matrix. There's stuff in B from an old calculation. It'll just get overwritten, so we don't need to worry about it. We're just going to go to edit A, 2 by 2, and I put in my data from my observed 36 boys with licenses, 32 females with licenses, etc. I'm going to go out. I may want to go back in and double check that I typed it incorrectly, and I did. Now I'm going to go to stat tests, chi-square test. Okay, observed in A, please put my expected in B, and I'll go to calculate. And there we go. So I will write that down. I will also then go into matrices and look at B and write these in my expected data. And here, I wouldn't bother to round to the 1 decimal spot because it's nicely ending at 2. So just write them all down. And we're going to go ahead and put them in our expected table. And if you look, I had already done that for you on your notes. Okay, so it looks like my notes are a little out of order of your notes, but I've already done that. Oh, I guess I did not. 1 second. I apologize. I was looking at an old copy of the notes. For you, you do need to go ahead and write this in out of your calculator or off the video. These are my expected counts. Okay, and notice that even though this is not the HOP test, the method for calculating the cell counts is the same. And the one thing we need to look at is, yes, all of these are greater than 5. So when we do our 5 steps, we can answer it. We actually also want to look at and see, do they match our observed data? And of course, they do not. They never seem to do that. So we'd say, at first glance, it appears that there is an association between gender and having a license, since the observed counts are different than the expected counts. However, it is possible that the variables have no association, and the differences we see are due to sampling variability. And I would prefer, instead of no association, the variables are, you could say, are independent. But you could write either one. Okay. To decide, I will conduct a chi-squared test for independence. Now, I much prefer the second version of the hypotheses, but you could write either one. The null being there is no association between gender and having a license. I prefer gender and having a license are independent. And the alternate being there is an association. And please don't ever say that. You could say, yeah, I just really don't say these. It's much, much better to say gender and having a license are not independent. Independent and not independent. Okay, and so we're going to check our conclusions. The data comes from a random sample of Hillcrest High School students that was given. Is the sample is less than 10% of the population? Yes, assuming there are more than 1,000 Hillcrest High School seniors. Okay, and this is not reasonable, but, so we'll proceed with caution. Okay, and then is the sample size large enough? Yes, all the expected counts were greater than or equal to 5. And so we go ahead and run our test, which we did. And we got a chi-square value of 3.01. Our degrees of freedom was 1 because there were 2 rows and 2 columns. And our chi-square value, again, would go here. So we were trying to find the probability of getting a chi-squared value greater than 3.01, assuming that they were independent. And that probability is 0.0827. Okay? And since our p-value is greater than alpha, there's an 8% chance I can fail to reject the null hypothesis and cannot conclude that there is an association between gender and having a license, or cannot conclude that they are not independent, something like that. And we will forgo this next example. Please get homework 5 done. Thank you.